This video is about infinite geometric series, and we only get this formula when your ratio is less than 1. So remember, our general terms are created in a geometric sequence by multiplying by a common ratio. So like here, we have 2, we multiplied it by a third to get 2/3, and then by another third to get 2/9, and then by another third. So our ratio is a third. And when that happens, we actually get this for our sum. So let's try one, and then I'll explain it to you. So if we look at our series here, we have 2. So our a sub 1 is 2. And we've been multiplying it by a third. And to do that, I just took 2/3, divided it by 2, and it gives me a third. So now we know, since our r, right, is less than 1. I'm putting absolute values because negatives would work the same way, but r is less than 1. We know that we can use this formula. So a sub s of affinity is just taking 2 and 1 minus a third. It's a pretty cool little formula. So this is just 2 times 3/2, which is 3. So if we plug this in and you watch it approach infinity, the sum would approach 3, this right here. So 2 plus 2/3 plus 2/9 plus 2/7 plus 2/81 plus so on and so on, it approaches 3. So I have it all plugged in. Our ratio is a third. Our first term is 2. And then this would give us our sum. So remember, if I have an I of 1, it's going to give us just the first term. So that would be 2. The sum of 2 is 2. And then if I go to 2, it gives me the sum of the first 2 terms. So that was 2, right, plus 2/3, which is 2.66. So let's see what happens. So as I approaches infinity, you can see that this is approaching some number. And eventually it just gives up and says 3. You can see it better up here. But yeah, it's 3. It's not actually, it's approaching 3 as you just keep adding these these terms off to infinity. So think of it like a half. Half is the best one to look at. If we're starting at 2, right, then the next term would be half of 2, which is 1. And so the sum of the first 2 is 3. And then half of 1 is a half. And so we'd get an extra half on there. And so on. So each amount that we're adding each time is half the amount that we added last time. See what I'm getting at? So this is approaching some number. So that distance that the thing you're adding each time is getting smaller and smaller and smaller. It's being halved and halved and halved and halved and halved and halved. So it's approaching some number, which in this case is 4. So our limit here, right, as we approach infinity is going to be 4. In fact, the sum is 4. Now what happens though is if we change this to a number that is bigger than 1 or even 1, you can see it goes off to infinity. You can see it just goes off quicker and quicker. So if I scroll out, it's not going to approach something. This sum grows bigger and bigger because every single time you're going to be adding something that's 1.5 times as big. So it's going to be huge as we keep going. So this means that r must be less than 1 in order for us to get to a sum. If our ratio is bigger than 1, this diverges. It does not have a sum. It's just going to go off to infinity or negative infinity, but it's not going to give us a sum. All right, so here's our problem here. We're going to go off to infinity, and we can see our ratio is 1/5. So all we now need is our a sub 1. And you may say, oh, my a sub 1 is 2. But be careful. That's n and that's n. So what you always want to do when you start these is to plug them in. You want to start with plugging in 1. And then 2. And then 3. You want to create your geometric series. Okay? So this would be 2/5 plus 2/25 plus 2 over 125 plus and so on. So our a sub 1 is 2/5. And yeah, you can say your ratio is 1/5, but if we test it, this is 2 over 25 divided by 2 over 5, which would be 2 over 25 times 5 over 2. Cancel, 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 and we get 1/5. So we already knew those two were good. The reason, but it was not 2 for our a sub 1. It was 2/5. The formula itself for finding the infinite sum is fairly easy. It's just a sub 1 over 1 minus r. Okay? So our s sub infinity here would just be a sub 1 So 2/5 over 1 minus 1/5. And so this is just 2/5 over 4/5, which is 2/5 times 5/4. Cancel, cancel. It's 1/2. So this sum will go off to infinity. And again, always make sure your r is less than 1. Otherwise, it's going to diverge. So we can watch this one grow. And you see it just keeps getting closer and closer to 1/2. So as we keep getting closer and closer, it has some limit. These are all the sums. That's the sum of 1, sum of 2, sum of 3, sum of 4, sum of 5, sum of 6, sum of 7. We're not looking at the terms here. We're looking at the sum of all the terms as they approach some number, which is 1/2. And so again, as long as your ratio is less than 1, this sum will converge to some number, and you can plug it into the formula and very quickly find out what it is. So what is happening here and why this is converging is you have to think this little r to the n here. If it's a fraction, then the limit of this as n approaches infinity, this guy is going to go off to 0. If you remember our rational functions, when the denominator was bigger than the bottom, we're getting basically 1 over, I'll call it f or fraction, to the n, right? And so this is going to go off to 0. And so if it goes off to 0, you end up with a1 times 1 over 1 minus r. So it's a sub 1 over 1 minus r. So there is our s sub infinity. That's all it is. You're just basically taking the summation formula for your geometric and throwing away to the r to the n. And there is your formula. All right, thank you.